Hi there, I'm Z, KJ7NLL, and today I'm going to show you how we turn this into this.
Julia 7 November Lima Lima from Kilo Golf 0 Delta.
So, let's jump right in. But first, I'd like to congratulate some students in Singapore who have started their own ham club. Gabrielle Kilo 7 Papa November Zulu. Rissa Kilo 7 Papa Romeo Uniform. Sanath Kilo 7 Papa Romeo Tango. Ramya Kilo 7 Papa Sierra Hotel. And Jaden Kilo 7 Papa Uniform. I'd also like to say good luck to Advaith on taking their ham test. I'd also like to thank the teachers for supporting the students and making this possible. Mr. Tanho Tech, Kilo 7 Papa Oscar Alpha, Hugh, Golf 4 Mike Romeo Echo, and Thamfu Hung, 9v1 FH, and Chula Peng, 9v1 YP. Good work putting together the club, and I can't wait to hear what you guys do. Now, back to problems and solutions. So, here we have a matching board, and actually here we have a matching board too, and why don't we just check out all these boards too? Well, that's a lot of matching boards, but I want to show you how we got there. So, here's a matching board, and this was one of our original matching boards. And as you can see, it's very simple. It has some capacitors and some inductors. But the reason why we needed to make more is, and we already had some, is because we had just done an upgrade to get more power to the antenna. We used to have a really long LMR240 cable, but it reduced the amount of power that we had significantly, so we switched it to the LMR400, but when I made my first communication at quote-unquote the same power level, we burnt out our old mat, so we had to make a new one. And it was hard because our antenna just wasn't the same. And the reason it wasn't the same is because we added carbon fiber rods for stability. And carbon fiber rods were used just to straighten out the antenna. Our antenna was very bendy because we used PVC pipe, and the PVC pipe bent. So here we have our matching board, and this is not the final one. This was actually one of our failed attempts. The real one's on the antenna, so I can't show you that. After we fixed all that, it was really hard to get a good match. So you might notice here, we made something. This is an artificial antenna. Now, an artificial antenna, it's basically something that mimics the characteristics of our antenna. Now, this is our antenna over here. And these are the characteristics, and you can notice it has a certain amount of impedance and a certain amount of reactance at certain frequencies. And so we tuned this little SMA connector with a variable inductor on it. Actually ended up becoming a wire. So we made this artificial antenna, and it worked really well, and we tuned it to the correct size and spacing, and yeah. So then we were able to plug this onto here and then measure our matching board without having to run all the way upstairs, run back downstairs, and get it fixed, and then run back upstairs and down and up and down, and it was just really hard. So then, when we figured out that we could just add this artificial antenna, it sped things up hugely, and so we were able to make our matching board really well. Now, here's a couple other things to note. You might also notice that we have these blue silver wire, and that's because RF flows on the outside of wire coils, and it doesn't flow in the middle. So silver is like one of the most conductive, or maybe is the most conductive metal that we know of. And so this is silver-coated wire, and it's actually jeweler's wire, because you can't find RF wire that's silver-coated, and so it's also got a nice blue tint, so it's pretty too. Now you might notice these huge caps can handle a lot of heat. Now these are mica caps, capacitors, so they're pretty much rock that happens to have a capacitance. So earlier we were using these surface mount capacitors, but these surface mount capacitors just can't take a lot of heat and can't take a lot of wattage or voltage. So we swapped out to the micas, and these worked for a little bit, but they also burnt out during power testing. So then we tried this, just another design, but eventually we settled for making our own FR4 board and just soldered a couple components on, and that's what ended up working. We used a couple micas, we used different inductors. Anyway, it's just completely different. So that's that. Now, the next thing I want to show you is this LNA, or low noise amplifier. And what it does is it takes the really weak signals that we're getting from space and amplifies them up so we can hear them. And so that little black chip right there is the chip that amplifies our signal. But we were getting a whole lot of noise. And when you get a whole lot of noise, it's very hard to pick out the signal that you're actually looking for from the noise that's just in your way. And it turns out that most of that noise was being caused by that little chip right there. And what that little chip does is it's a boost amplifier. And what it does is it boosts our voltage to above 5 volts so that on this side, that teeny tiny little chip here can buck it down to exactly 5 volts for a clean 5 volts into our chip right there. But the problem is, a boost converter is very noisy. And the reason it's noisy is because inside of it there's an inductor, and it has a magnetic field. And that's the entire way this works, is it has a magnetic field. And so that it builds up, and then it collapses. And that causes a big disruption in the signal, and that's what causes the noise. So we removed it, we removed a couple other things, we replaced it with wires, and it worked magically. So the next thing I want to show you is I2C boards. And the reason we have these is because our cable was about 50 feet long. It was going to the antenna, and it had to carry some very important signals back to us, and they had to be accurate within millivolts. We measured the voltage from the potentiometer 50 feet away from the actual potentiometer. So when you do that, you get very noisy signals. And on top of that, we also had a 12-volt signal right by, next to it. And because these things have to be accurate and precise within a millivolt, we made this. And this here has 2 parts. It has this side, and it has this side. This side is the antenna side. This side is the base station side. And what these boards do is they allow us to take that 50 foot and turn it into 5 centimeters. And the way we do that is because we have I2C here. And on the back, you can see a little I2C chip. And so, we have this board, and the way they work is we have a little ADC for measuring our voltage on here, and that's that teeny tiny little chip there. And what that teeny tiny little chip does is it measures the voltage that we put through our potentiometer. And we had to rewrite our code a little bit to get it to work. But it ended up working great. So the way this works is we take all this stuff that we plug in here, like I2C, EWM, 5 volts, and we send it down a shielded Ethernet cable all the way to the other side at the antenna, where we select our address with this little shorting thing. And after we get there, we can now nicely measure with our ADC chip. And so it just worked very well, first try, pretty much. And yeah, that's all I have to say about that. So here we have our diplexer board. So the diplexer board here, you may notice or realize that it's the same one I used on a couple of my other videos. In fact, it was a first one that we tried to use on our helical antenna. But one of these burnt out really fast, or it had a bad match or something. I don't remember why. But it wasn't a very good board. So we replaced it, and completely redid the design. So we have our little extender over here, and this has a bunch of problems. Mainly these two capacitors. They melt. Those kinds of caps just don't work well under heat, and by the way, that's the same kind of capacitors we used to use before we went to surface mounts and eventually micas. Now, we were using these on here, and we actually ended up switching completely to surface mount and just inductor and surface mount with some more of our jeweler's wire. Well, in this video, we talked about some of the problems and solutions we had in our project. So, some of the problems we had were our diplexer, our LNA, and our matching circuit board, and some of the solutions we had were like the I2C and the microcapacitors and stuff like that. Now you may also notice a new addition back there, that's a 3D printer that we're going to use on our projects, so that's exciting. And that's about all I have to say. So 73 characteristic dipole impedance, and I hope to see you next time.